Welcome to this audio version of the Oil and Gas Engineering Guide. We will start with an introduction to give you an overall picture of project development and engineering execution, and then we will focus into the work of each and every engineering discipline, describing its work and the documents it produces.
What happens when an oil and gas company decides to develop a project? First of all, the company planning, business planning, or pre-project department performs a technical and economic assessment of this new development. What business benefits will it bring? What is the feasibility, technical feasibility? What is the cost? So what is the rate of return, and so forth? This process is carried out internally within oil and gas companies, since it involves a lot of coordination, for instance, between reservoir department, as well as financing, technology, and so forth. This step is called the pre-project or the conceptual phase. The main objective is to define the functional requirements of the project, as well as to obtain a preliminary cost estimate of the investment. This step 1, is sanctioned by a decision to go forward into step 2 or not. Since step 2, which will be further refining the, for instance, technical feasibility of the project, will involve significant amount of expense. So at the end of step 1, there is a gate where the decision is taken based on the assessed attractiveness of the project, whether to proceed to step 2 or not. Step 2 is called the front-end engineering design. It involves a specialist, a contractor. So this time the oil and gas company does not do this internally, but enters with a service contract with a contractor that is specialized to develop such preliminary plant design, whose objective is to refine the cost estimate up to a very precise level of plus or minus 10%, which is a level required to take the final investment decision, which will be taken at the end of step 2. At this stage, the plant design is developed, and to a rather high level of details, which then will allow, should the investment decision be taken, to move to the next step, which will be step 3, which will be the project execution stage. And this will normally be contracted by the client, the oil and gas company, to a contractor under a fixed price project contract called a lump sum turnkey contract. In other words, at this stage of step 3, company has entered into a contract with a contractor for which it will get a turnkey plant for a fixed price and for a determined delay. This presentation, which is an introduction to plant design, will look at step 2 and 3. If we look at step 3, which is detailed, what is called detailed design, compared to the step 2, which is basic design, we see that this is only a small part of an overall project execution. project execution indeed not only involves design, but procurement, manufacturing, shipping, installation, construction, inspection and tests, and handover to the company. So here we are only looking at the first stage of the project, which is the design. Let's see how design is organized. Well, when you see a picture like that, you may wonder how all the various trades, the design trades, work and are coordinated. In fact, there are a number of trades involved in an oil and gas facility. First of all, there will be the process, which is defining the process scheme. Then we have mechanical, which is selecting the mechanical equipment, the rotating equipment, the pressure vessels, and so on. Then we have the plant layout discipline, or the plant architect. We have also civil, which is in charge of the earthworks and the foundations for the equipment. And for sure, all these equipments are connected with pipe work. So we have piping. We forgot to mention electrical. All these power consumers have to be fed with electric power, as well as instrumentation and control, because the plant process has to be monitored and controlled. Last but not least is safety. This facility has to be designed in a safe way that it can handle emergency situations. Engineering is organized in disciplines, and the traditional disciplines are shown on this slide. There we find the process, which actually comes first, safety, the discipline equipment mechanical in charge of machinery, any type of equipment, pressure vessels, heat exchangers, rotating equipment, fired equipment such as boilers, turbine, and so forth. Plant layout, piping, civil, instrumentation and control, and electrical. Now that we have seen how engineering is organized, let's have a look at the deliverables, at the production of engineering. Well, engineering production is paperwork, drawings, and specifications, because the role of engineering is twofold. First of all, is to produce all the bill of quantities and the specifications required to purchase all the plant equipment and materials. And the second role of engineering is to issue all drawings necessary for the erection of the plant. This means that engineering issues an awful lot of documents. How to get oriented into this huge bunch of documents? Well, each document has a document number, which shows which is the issuing discipline, what type of document this is, the serial number, the title, and the revision, because engineering documents undergo revisions as the design progresses. So with this simple key, we can get oriented into any engineering deliverable by quickly knowing the issuing discipline and the type of document. Even though there are thousands of documents issued on any typical size project, these documents are only of a few types. For example, piping issues general arrangement drawings for each of the plant areas, so there might be 300 of them, but they are all of the same type, piping general arrangement drawing. In this course, in the different modules, we will have a look at all the common engineering deliverables issued by each discipline, which are shown on this slide. It's a very small writing, don't mind that, we will see this in the different modules. So at the end of this session, you will be familiar with all the document, drawings, specifications. Let's have a look now. Let's give you an overview of the plant design. I will now give you an overview of how a plant is designed and the sequence of work of the various disciplines. It all starts with the business case. The business case defines the plant capacity, the feedstock composition, as well as the product specifications. Process will perform simulations and will define a process scheme to achieve these product capacities and specifications. The result of that will be to issue a process flow diagram and heat and material balances. The heat and material balances show the conditions in all process streams as well as the duty of all the equipment involved in the process. This heat and material balance will therefore serve as the requirements to define the duty of the equipment, which is the next step of the engineering design. The process equipment sizing or specification. Why or specification? Because process does not size all equipment. Process will only size phase separation equipment such as this gas-liquid separator and some standard size of heat exchangers such as shell and tube heat exchangers. However, process will not size rotating machineries such as compressors, pumps, turbines, and so forth, as well as other types of equipment such as fired equipment, such as this boiler here, and specific type of heat exchangers such as air coolers, plate heat exchangers, and so on. For this type of equipment, process issues a duty specification which only shows the duty, i.e. for this compressor, the flow, the inlet pressure, outlet pressure, and of course the fluid composition. The sizing will be left to the vendor. To perform its design, the vendor needs the specification from process and also the material of construction of the equipment. This is defined by another discipline, the material selection and corrosion specialist. He works from the list of fluids and their composition and condition in the various parts of the process. Based on calculated corrosion rates, he defines the material of construction for the various equipment and pipes of the unit. Once the vendor has performed its design, he is able to provide dimensions of the equipment to the engineer, which enables to define the plant layout. Plant layout, which results in the production of what is called the plot plan, shown here, a plan view of the plant with the various equipment, is drawn using the process flow diagrams, which show which equipment is connected to which, the process data sheets for the equipments that are sized by process, as well as information from vendors for the equipment which are only specified by process, such as this compressor. Information from equipment vendors are not only required to perform the plant layout, but also to design the utilities, Indeed, the utilities of the plant have to supply the required amount of cooling water, fuel gas, steam, and so forth to the equipment. In addition, the equipment vendor will advise the power consumption of their equipment, which will allow to size the electrical power generation and distribution, including defining the texture of the electrical distribution, such as the one shown here on the single line diagram, and sizing all the distribution equipment such as transformers, switchgear, and cables. Information from vendors is also required to design the civil works, in particular the equipment foundations, because vendor will advise the load and the size, the footprint of their equipment, so that they can design the proper foundation. The process design is further developed from process flow diagrams into P&ID, piping and instrumentation diagrams. P&IDs show all the equipment, piping and instrumentation, as well as valves. It is the main document for the plant operation. So it's very much discussed between the plant owner and the engineer during the design phase. As it defines the piping, it allows piping routing to proceed, including the routing in 3D model and the production of piping fabrication drawings and bill of materials. Besides piping and valves, P&IDs also define all the instruments and controls that are required for the operation of the plant. They therefore are the starting point for the instrumentation discipline to purchase these instruments as well as the control system. Once piping is designed, the structural steel that is required to support the pipe work, such as pipe racks, as well as the structural steel needed to provide access platforms to operators to access valves, instruments, and equipment, is designed, such as this pipe rack, and the corresponding drawings are issued by engineering to the structural steel fabricator. That's it. This is, in a nutshell, the sequence of work between disciplines, each represented by a different color, for the design of a plant. As explained,
this introduction is now concluded. In the coming chapters, we will go through each of the engineering disciplines and explain the work and the deliverables it produces.